The binding energy per nucleon is the binding energy of a nucleus divided by the number of nucleons in the nucleus. The binding energy per nucleon indicates relatively how firmly the nucleons in a nucleus are held together. It is a measure of the stability of a nucleus. Click the steps to see how the binding energy per nucleon of a nitrogen nucleus is calculated. The graph above shows the variation of the binding energy per nucleon with nucleon number A for different nuclides. Each red dot on the graph represents a nuclide. Click the View button to see the name of some nuclides. Note that, except for the lighter nuclides, the binding energy per nucleon is approximately 8 MeV. Nickel-62 has the highest binding energy per nucleon and its value is 8.8 MeV. Which nuclide has the lowest binding energy per nucleon? Answer: Deuterium has the lowest binding energy per nucleon and its value is 1.2 MeV. Nuclides with nucleon number A between 40 and 80 have high binding energy per nucleon. This indicates that nucleons of these nuclides are more firmly bound. Hence, these nuclei are more stable than those having A less than 40 or A greater than 80. Click the Stable Nuclides button. The three peaks shown that helium-4, carbon-12 and oxygen-16 are light nuclides which are unusually stable. How many protons and neutrons does each have? Answer: Helium-4 has 2 protons and 2 neutrons. Carbon-12 has 6 protons and 6 neutrons, while oxygen-16 has 8 protons and 8 neutrons. Light nuclei which are stable normally have equal number of protons and neutrons. Can you suggest some nuclides which have this property? Click the Same Number button for some examples. In nature, there exist both stable and unstable nuclides. Click the Stable Nuclides button to observe the plot of neutron number N and proton number Z for stable nuclides. Click the Unstable Nuclides button to observe the plot of neutron number N and proton number Z for unstable nuclides. Stable nuclides with Z less than or equal to 20 tend to have the same number of protons and neutrons. Click the Z less than or equal to 20 button. For Z greater than 20 or less than 83, stable nuclei contain more neutrons than protons. The ratio N over Z for stable nuclides increases gradually from 1.0 to about 1.6 as the proton number Z increases to 83. Click the Z greater than 20 or less than or equal to 83 button. Nuclides with Z greater than 83 are unstable. Click the Z greater than 83 button. Summary. The binding energy per nucleon is the binding energy of a nucleus divided by the number of nucleons. Nuclides with nucleon numbers between 40 to 80 have high binding energy per nucleon. For stable nuclides, if Z less than or equal to 20, N equals Z. If Z greater than 20 or less than or equal to 83, the ratio N over Z for stable nuclides increases gradually from 1.0 to about 1.6 as Z increases to 83. Nuclides with Z greater than 83 are unstable.